Hi everyone. Today we are going to see how we are going to integrate IoT with MuleSoft. We'll go by step. We have a process to do it, and let's see how we are going to do. First things first. First thing which we need is we need to download the Raspbian OS because we have Raspberry Pi which needs an OS. So go to google.com and search for download Raspbian. Once you click on www.raspberrypi.org and go into downloads, you will find two OS. One is the Nodes and the other one is the Raspbian. We are going ahead with Raspbian OS. Just click on Raspbian OS and you can see there are multiple downloads. For this, we are going to download Raspbian Buster with desktop and recommended software. I am downloading the zip file and the download starts. It will take a while to download. It is of 2.5 GB. Once I downloaded, you can see here that disk image file is downloaded. You will be getting a download of a zip file, extract it, then you will see a disk image file. Further, the disk image file needs a software to write into our SD card. Now, if you can see, when we insert a SD card, for this we need at least a 16 GB of SD card free space. So it's always better you have a 16 GB free SD card with you. Plug in the SD card and you can see I have this OS already existed, but I wanted it to be formatted. But you can see it shows only 200 or 252 MB. So even if you use the format which is present here, it will show only the 252 MB free space. So to format it properly, we need to download SD card formatter. Go ahead and open SD card formatter, and then automatically the folder will be selected and just click on the format. Then the SD card is formatted perfectly. If you go ahead and see, the available free space will be shown as 14.58 MB. The next part is we need to download Win32 disk imager. This helps us to transfer the disk image file to copy from our system to SD card. If you open this image, this Win32 disk imager, you can see the device G already selected, which is nothing but our SD card. And now select the image file which is already present in our downloads. If you see here, click on the disk image file, open it, then you can see the write option is enabled and it will be written into G drive. Just click on write and say yes. It will take a while. You can see estimation time is 8 minutes. It will download. It will write from your local to your SD card. So as it is approaching to complete its process, just you can see that you have downloaded the Rasbian OS, you have formatted the SD card, and you have unzipped the image file. Once this is completed, we shall add a SSH file in the SD card folder. You can see the write is successful. Go back to your folder, and if you can see, open the copied version of the disk image file. You can see, create a new text file with name SSH. This helps in connecting our Raspberry Pi with our laptop. That's it. Now you can unmount your SD card from your system, and then we should start connecting to our laptop. Safely eject the SD card and then keep this SD card into your Raspberry Pi slot. Open the Network and Internet Sharing Center. Click on that. Scroll down. And you can see Network and Sharing Center. Once you plug in your LAN cable from the Raspberry Pi to your laptop, there are two ways that you can connect your Raspberry Pi to your laptop. One is through HDMI cable, which doesn't require any LAN or Ethernet connection, or through LAN using Ethernet. So in this process we are going to use our LAN cable via Ethernet connection. If you can see, once the LAN is connected, there is already a connectivity in my laptop using ActFiberNet. Once you plug in your LAN, you can see an unidentified network shown here. You can see there is an unidentified network, public network shown below. So now we need to share our internet which we are having to Raspberry Pi. For that, click on the connections, open this properties tab, go to sharing, make sure that these two boxes are checked and the Ethernet should be highlighted automatically. You need not do anything. Just click on OK. For me it is already there. Now then click on the Ethernet, go to properties, click on Internet Protocol version 4. Check that there is automatically the IP address automatically generated. There is no need for you to enter anything. This IP address we will be using to connect to our Raspberry Pi. This would be our host name, or this would be our static IP address to connect to our Raspberry Pi. After everything, just click on OK once it is done. That's it. Now go ahead and open Xming. Xming is something which we use to see the UI part of our Raspberry Pi, the GUI part of our Raspberry Pi. So please download Xming from the downloads. Now click on Putty. Putty is used to connect to our Raspberry Pi. I have the connection already there. You can see the host name is raspberrypi.mshome.net, which is default name. Let me write some steps. Connect through Putty Raspberry Pi. Host name as raspberrypi.mshome.net. You can see the port is 22. Now go to the SSH tab, expand it, go to X11 and see that these are enabled and checked and all these are automatically generated. Now go back to the session, click on Raspberry Pi and open it. You can see a warning where you can say yes. That's it. You need to log in as a PI user. The default user for Raspberry Pi is PI. Now it asks for the password and the default password is Raspberry. After hitting it, you will come back here. I'm just writing the username and password over here, the default which comes from the Rasbian OS. My username default is Pi and the password by default is Raspberry, which we will be changing in future. It's always better to change your password for future products. Now write the command start lxde, which will open your Xming GUI. In this way we can see the UI part. You can see there is SSH enabled because we have created a text file while writing it to the SD card. This is the UI of Raspberry Pi, the OS. You can just open the browser as well. You can create a shortcut for your terminal, LX terminal, which we use to write commands. Add to desktop. You can see the browser opening. Now open the LX terminal, and first things you need to do is type sudo space raspi-config. Make sure that raspi should not have any space in between. So sudo space raspi-config. You will get a dashboard where you can change your password. Select, press enter, again press enter, and now change your password. I have given my password. Your password won't be shown here because this is Linux. Retype the password. Your password is successfully changed. Press enter. Go down with your arrow buttons using down arrow and side arrow and click on finish. Now you can see your password is updated successfully. Next thing you need to do is you need to check the Java version currently installed. If you can see here, by default we have Java version 11.0, but I want to install Java 8 version in my Rasbian OS because I felt when we have done this before, we have some issues with Java 11 versions for permissions and all. So now we are going ahead and removing the Java 11 version which we got from Rasbian OS pre-installed, and then we will be installing Java 8. So to remove the Java 11 version, use this Linux command sudo space apt-get space purge and open JDK. It will ask for yes or no. Click on yes. This command is used to remove current Java. So click on Y so that the Java will be uninstalled. You can see that it is removing. Next, this command is used to install Java 8 version. Once the Java 11 is uninstalled, use sudo apt-get install openjdk 8-jdk. This is to install Java 8 version. You can see the Java is uninstalled. To check again Java space -version, you can see no such file or directory. Now go ahead and install Java 8 version. Copy the command, press enter. It says invalid operation. That means my command is wrong. I am missing something. I am missing hyphen over there. Make sure that you use proper Linux commands. So you can see that it is starting downloaded. Click on Y, say enter Y, type Y and enter it. So sometimes it takes time to download this Java because we are downloading it from the command line. Though it is 25 MB, it may sometimes takes more than 8 minutes depending on your internet connectivity. Let's wait for it to download. You can see 99%. It is unpacking. It is updating and processing everything. You can see that is done written over there. Now go ahead and check the Java version, Java space hyphen version. You can see that Java 1.8 version is installed successfully. So this is the best way to download the Java version, or it is the best way to remove the existing Java version. Just two commands, one to remove the existing Java version and another command to install it. Now the next step is next, go ahead and open the browser in your Raspberry Pi and download Mule 4.2.2 standalone server. You can do this by running a Linux command as well, but it is not necessary. You can open the Google Chrome and download the Mule runtime manually. We have 30 days free trial. Enter your first name and last name and complete the details and click on the download. It will start download. You can say though it is of 250 MB, but in this way the download gets completed soon. Meanwhile, go to the terminal back and click on sudo space su space hyphen. This will go to your root user. Now we are going to create a user with name Mule, so that all my MuleSoft applications or MuleSoft operations will be controlled only by one user, MuleSoft, rather than going ahead with PI user. So this command is used to create a user called Mule. User adds space hyphen s space everything. You can see the command over there. Now enter, give the command PASSW password space Mule. That will ask for you to type the password, new password. Retype the password and the password is updated successfully. Now you have created a new user called Mule. Now go ahead and create a new directory using command mkdir space home mule and also opt-mule. This will create the directories. You can see we are using change owner command. Please follow these commands in the same way. You can see the download is still happening. If you can see into my folder section, my download is completed. Click on that and you can see show in folder, the same how we see it in our Windows OS. So my standalone is downloaded in downloads. Go back. Now change the user to PI again, su space PI. It will go to PI user. Go to the root folder of PI. Now go to the folder of home PI downloads, because you need to give permissions. You can see it is highlighted in red. That means we don't have permissions for that, writing or executing permissions other than the PI user. First things you need to do is unzip this Mule EE Enterprise Edition distribution standalone server. You can use this command. You see that it is saying cannot find or open. Okay, but the thing is you need to use the command unzip space the folder name directly. You can see it is unzipping. So upon successfully unzipping it, just go to the downloads and see that there is a folder called Mule Enterprise Edition without zip. This folder is nothing but which we have done after unzipping it. Now use the command cp copy space -r, copy the folder name, paste it. So you are basically moving this particular folder into opt-mule, which we have created for the user Mule. because I want all the files and things to be under Mule. Now you can see here, you are going to the user Mule, okay, then down, if you can see, you are giving some permissions to it. Now we need to give all the permissions to execute or to run these files. You are inside Mule user now. We are unzipping the zip file which we had already, the same way which we have done. You can see that there are permissions error, permission denied error. That's the reason. What you need to do is use chmod 777, that will give the access permission to the device. Okay. Please follow this step by step. LSLDR will give the list of files present in that particular folder. Now go to Mule user and into OPT Mule folder, unzip it to start unzipping. You can ignore the previous step as well, where we have unzipped this Mule Standalone server with PI user. You can do this with Mule user. You can see the unzipping is successful, and now you are in Mule user. Just check that if it is unzipped or not. You can see that there is a folder created. Now copy the name of that, go into the folder. You can see that there are many files and folders: config file, bin file, apps file. Apps file is where we deploy our applications. Now we need some additional config files required to perform a successful deployment of our Mule applications. So these are the 4 commands. I will be sharing these commands in the description part. Just copy those commands and execute them. Go ahead and go to cd space opt space mule folder. Paste the command, it will start downloading a file. Now go ahead and give the other command. It says no such file directory. Make sure that you are giving proper. You can see my folder name of Mule Enterprise Edition EE, but here it shows just standalone. So make sure you give proper commands. I'll share these commands in my description. Copy them. Now you can see those files are present. Now copy this Mule Enterprise Standalone 4.2.2. Go inside it and see, and go into the bin folder. If you go to the bin folder, you can see there is mule file.patch and there is another mule file. So use VI, which is used for visual editing. Scroll down and make sure that you are giving proper memory allocated. You need not change anything for Mule file here because we have already downloaded the latest 4.2.2 version of Mule Standalone runtime. We are good till now here. You can see here, go to the PI user again and go to the Mule user, check for, go to OPT and Mule folder. You can see there are some files. Go to Mule Enterprise Standalone folder, open it and go to the config folder, cd space conf, and then you can see there are some folders. In that we are going to conf folder. Again check what are the files that are present in config folder. There edit the wrapper config file to make some changes. You can see, scroll down where the memory allocation is given. Just scroll up. There we go. There is initial Java heap size and there are initial minimum and maximum. Make it to 256 and 512 MB. Now again go to the folder, go to the Mule user, enter the password, and now go to the Mule folder, Mule Standalone folder, cd space, copy that particular folder name, enter it, and go to the bin folder. You can see there is a Mule file in the bin folder. Now once you hit /mule, the server gets started. Mule Standalone runtime is getting deployed. You can see it is launching. You can see it is deploying automatically. Mule runtime. You can see the status domain is deployed. In this way, it's very easy to deploy our application. We haven't deployed our application yet, but the server is up and running. Now, there is an application already developed on my local Anypoint Studio. So, to transfer that application from my Windows OS to our Raspberry Pi, we will make use of Winscp. So, if you can see here, I am opening Winscp and giving my hostname as raspberrypi.ms.home.net, and then I am clicking it. Click on the username pi. The username is pi and enter your password which you have changed earlier, and just click OK. You can see left hand is my Windows OS and right side is my downloads folder of Rasbian OS. This Rasbian temperature new -1.0.0 snapshot is my Mule application which is already deployed. I am copying that Mule application into my downloads folder. You can see the transfers happen successfully. The main part here is now. Go to the new tab. We need to give necessary permissions to our Mule file to execute or run successfully. So make sure go to the download folder and give necessary permissions to your mule application jar file. For that, use two commands, chmod 777 and give the file name, and chmod a+x. This will give execution permissions to the application. Then go to the mule user, enter the password, copy this particular jar file. Next step is to copy this particular mule application, which is a jar file, to your Mule Standalone Runtime Apps folder. First go to downloads, see whether this particular application is present or not. Now copy this from your downloads as a mule user to opt. If you go ahead and check, you can go to the Mule Standalone path, you can copy it from here, opt mule bin, paste it, remove bin, and keep apps. Apps is the folder where you place your applications. If you see here, once the application is automatically placed in apps, as our Mule Standalone runtime is up and running, the applications will start deploying automatically. Wait for it to deploy automatically. You need not do any special things over here. You can see the file is there in apps folder, and you can see the application is getting started. It is starting to deploy. You can see here starting app Raspberry temperature. You can see the app is started. Okay, if you go ahead, you can see there is an anchor text file also created once the application is created in your apps folder. That means your application is deployed successfully. Go ahead and run the application. My application is running on localhost 8081/test. I'm going to pass the number, my mobile number. When you hit the application, the internal Python scripts will be running. You can see that it in your console. Working temperature.python file is to sense the temperature. It sensed, and then green light is lighted. I'll show that video to you. So in this way we have successfully deployed our application and connected with our Raspberry Pi. Make sure that you have your Python files in your downloads folder, because that's where we have given the path in our Mule application. You can see my Python scripts over there. I will share my Python scripts in the description, and give all the necessary permissions that we have given before, chmod 777 and chmod a+x for the files, so that it has all permissions to get executed. You can see here, this is my one of the Python scripts which I have used. This is the 26th GPIO pin that I have used to connect it. I'll share these details in my description. You can see here, I have received my message. See, the temperature is 22.687 degrees. You can see in the database 22.562. You can see the temperature details. As you can see, I have all my Python files after giving all necessary permissions. Let me quickly explain you the Mule applications which I have developed. So if you can see here, I am taking my phone number from the query parameter. I am setting that into a variable. Then I am using a Groovy script the execution scripting module. Go to scripting module, use the Groovy script where you will be placing your Python file place over there. That will run your Python script where it will execute the temperature, store the temperature in the variable, and then if you can see here I am saving it in attributes.queryparams. Then I just try to open it. You can see here my scripting module. I have defined the command and I have given the path of my Python script where it is going to sense the temperature. So next, after that, save the temperature details that is coming from the Python Raspberry Pi, the sensor which you have used. That is nothing but the payload.input stream which has the temperature. Worst scenarios give the default value as 10, but payload.input stream will give the temperature which is sensed. Now if you can see here, we have used a Twilio connector to send a message to your mobile number. The Twilio connector will expect a message to be in this kind of format with body, from, and to, and then use as object with class org.mule.modules.twilio. Then send the message using Twilio connector. See the configuration of Twilio connector, which needs account SID. Create a Twilio account first. Give the account SID, username and password. And then if after sending your message to a mobile number successfully, use the green light Python script which will light the green light. You can see the Python script, and then give a final success record message. If your message sending is failed, go to the red light script in on error continue and light the LED light. So finally, this way we are connecting our Raspberry Pi to LED lights, the resistors, the combination of pins and all. I will be explaining that in the description part at what pins we need to place this temperature sensor. If you can see over here, this is our temperature sensor which is used to sense the temperature, and this is our green light. After successfully sending our message, it will light, and then on failure it will have a red light. So if you can see here, we are using the jumper wires to connect from our Raspberry Pi to the breadboard. We use female to male, male to male, and female to female jumper wires. All those things will be mentioned, and that's it. This is how we have integrated our IoT with MuleSoft. It is very easy to deploy a Mule application into the Rasbian OS, but thing you need to concentrate is make sure that you have a pre-setup of Raspberry OS. We have seen how we have installed Java, how we have installed Mule Standalone, and how we are giving necessary permissions to it. So hope you will come up with new ideas and you do some innovative things. I believe that this video will help you to do further experiments. Thank you all. Thanks once again. All the things which I mentioned that I will be providing in the description part will be provided with. Thank you.